Assalamualaikum, this is our group project for subject MAT560 Vector Calculus in the topic of Divergence Theorem. This is our team members. First, Muhammad Anwar bin Muhammad Darji. Second, me, Muhammad Adaiman bin Ahmad Junadi. And lastly is Muhammad Hanif bin Abdul Razak. For the introduction, the divergence theorem, also known as Gauss theorem, relates the flux of a vector field across a closed surface to the volume integral of its divergence inside the region. The theorem was first stated by Friedrich Gauss and later proved by Mikhail Ostrogradsky. The divergence theorem states that the total flux of a vector field out of a closed surface equals the integral of the field divergence over the volume inside. The divergence theorem states that the total flux of a vector field through a closed surface equal the volume integral of the field divergence inside the region. Double integral S f dot n derivative S equal to triple integral G divergence F derivative V. For a vector field f xyz equal to p xyzi plus q xyzj plus r xyzk, and the divergence is given by as stated.
Okay, next I'll explain on the data elaboration. Firstly, let E be the solid bounded by xy plane and parabolic z equal to 4 minus x square minus y square, so that S is the surface of paraboloid, together with this in xy plane that form its bottom. If fxyz is equal to xz sine yz plus x cubed cos yz 3zy square minus ex square plus y square. Find double integral of f dot n ds using divergence theorems. Question 2. Use the divergence theorem to compute the value of flux integral, double integral, vector f dot vector n ds, where fxyz is equal to 3x plus y cubed, xz plus y, z plus x to the power of 4 cos x square y, and S is the area of the region bounded by x square plus y square is equal to 1. X is more than or equal to 0, y is more than or equal to 0, and z is between 0 to 1.
To solve the first question, we need to find the flux integral by using the divergence theorem. In order to do that, we need to find the divergence of vector field F. So, we use the divergence formula to find the divergence of vector field S. Then, we get the answer is 3x squared plus 3y squared. So, we substitute the value into the triple integral, where we get the triple integral 3x squared plus 3y squared. And in order to solve that, it is more easier to use the cylindrical coordinate. Hence, we convert Cartesian coordinate into the cylindrical coordinate and solve this triple integral, and get the answer is 32 pi. Move on to the second question. We need to find the flux integral by using a divergence theorem. We are given a solid S where it's bounded by x squared plus y squared equal to 1, s and y greater than 0, and z between 0 and 1. The first thing we need to find is the divergence of f. So we use the same formula to find the divergence of vector field f and get the answer equal to 5. After that, we substitute the value of 5 into the triple integral. Same with equation 1, we convert it into the cylindrical coordinate and solve it. After that, we get the answer is equal to 5 pi over 4.
Now, we move to maple solution for the problem 1. For the first step, we command with vector calculus with semicolon. So our output will be like this. The second step, we command with plots with semicolon. Here is the output we obtain. For the next step, we command set coordinates Cartesian xyz, and here is the output. For the fourth step, to define our vector field, we command f equal to xyz, vector field as stated, and then the output result will be like this. Our next step is to compute the divergence of the vector field f. The command is divergent f xyz, and we get as the result. For the next step, we want to set up triple integral. The command will be like this, and the result as shown. And finally, we command to execute the integration. The command is same like before but without init. And the result of the integration is 22 pi. Move to the Mapper software solution for problem 2. The first command is with vector calculus with semicolon, and the result is this. The second command is with plot with semicolon, and the result of output as shown. The next step is we command set coordinates with semicolon to define our coordinate system as the 3D Cartesian system with the variable x, y, and z. The fourth step, we command like this to define our vector field. Then the output will be like this. For the next step, to visualize our vector field, we command field plot 3D f x, y, z, and we obtain the output as stated. We command divergence f x, y, z to compute the divergence of the vector field, and we'll get 5. We call s to solve the triple integral, and the result we get is 5 pi over 4. For the second last command is like this, and the result is same like before. The last is the command to set up triple integral, and the result as we show.
Okay, next, for the result, the divergence theorem provides a strong link between flux of a vector field across a closed surface and the behavior field within the volume enclosed by the surface. It simplifies complex surface integral into volume integrals. It's fundamental in physics and engineering applications such as fluid dynamics and electromagnetism. By understanding this theorem, it strengthens our grasp of relationship between local and global properties of vector field. Finally, we have achieved the objective to calculate the divergence theorem. As we can see here are the references. Firstly, we refer to Neil O 2022 for the multivariable calculus. Next is Lee S 2025 on 28 May, Mastering Divergence Theorem. And lastly is Strang, G, and Herman, EJ 2025 on January 17, the Divergence Theorem.